Welcome back to part 5, where we'll be calling functions that do not even exist. We'll also briefly touch on pitfalls, failures, and retrying to make our code more robust, as introducing AI tends to make our code a little bit more unpredictable and therefore potentially fragile. Now, why would we want to call a function that doesn't even exist? Well, technically we won't be calling the function at all. We just pretend that it exists and give ChatGPT a description of this non-existent function. Why would we do this? Well, for the arguments. You see, this new function calling ability gives us the side effect of being able to use ChatGPT to extract structured data directly into actual objects. For example, when we called this getWeatherForecastingLocation function, ChatGPT generated this object for us with a location key set to Amsterdam and a days key set to 3. So we're extracting structured data from some kind of text. Instead of getting a textual ChatGPT response, we can actually get formatted objectual data. So say we have a large piece of text, and this is probably a bad example, but just we want to extract all the names of people and their birthdays from some piece of text. And let's assume they do not have the same formatting for the dates, so we cannot just use a regular expression to look for patterns and matches in this text. We could of course feed the text to ChatGPT and just ask it to provide us with the names and birthdays, but even though this answer would probably be reasonably well formatted, it would still just be a piece of text containing the names and birthdays. We would then have to go and code something to parse the resulting text and make it into an object, and then we'd have to pray that ChatGPT will use the exact same format every time, which it won't. And then we also have the problem of ChatGPT's tendency to provide introductions or extra filler in its answers, which would again mess up our parser. And all of this gets very hairy and unreliable quickly. But what if we pretend that there was a function, and this function requires a list of persons and their birthdays in a fixed format as parameters? We can feed ChatGPT the text containing all this data and ask it to call this function, which doesn't exist but no matter, with the extracted names and birthdays as parameters, so we get an object. Now ChatGPT will return a function call, as we've seen many times before, but we don't have to actually call the function. We can also just extract the arguments if we want to. So in this way, we can actually extract structured data objects by calling ChatGPT, which again is mind-blowing, and this alone makes function calls super powerful, even if we're not going to call any functions at all. So let's whip up an example. Okay, so we'll start with some setup, as you're probably used to by now. Inside your utils folder, make a file called reader.py. And inside, you're going to code up this simple function, which takes a file path as an argument and then opens it in R or read mode. We use with open as a context manager to make sure the file is automatically closed again after we're done with it, so we don't have to worry about calling a close on this. And we then simply read the file and return the content. Go ahead and save and close this file. And now let's create a new prompt setup in our prompt setups folder, and we'll name it extract.py. Inside, we'll declare a simple variable containing our prompt setup as a string. You will be provided with a block of textual data. You will also be provided with a function. Your job is to call the function with the correct arguments. To get these arguments, you will need to methodically extract them from the textual data provided. So we can go ahead and save and close this file as well. Let's create the function description next. Create a new file named extract.py in your function descriptions folder. And our job in here is to pretend we have a function and describe how it works to get ChatGPT to pass the correct arguments to our non-existent function so we can extract data from the arguments. I'm going to be extracting certain events from a historical text and the dates they occurred. We'll pretend for ChatGPT that this function will somehow draw a nicer representation of the data and therefore needs the data as arguments. Now, this is a pretty long description, but it's not that complicated. We have a name, make list of dates, the description, and we're just pretending that this function will return some kind of nice table representation of historical dates and their happenings. And the input argument instructions, the input should be an array containing arrays structured exactly like this. So it's going to be an array of arrays, and each array in the outside array will have a date and a happening. Each item in each list should be a string, and the date must come first. The happening should be a single sentence description. Example given by Battle of Waterloo, Napoleon defeated. Make sure you include all happenings for which you can find the date, but not unknown dates. But only include happenings you extracted from the user provided text. So trying to stop it from just hallucinating extra data that's not actually in the text. Then we give an example, 1592, Japanese invasion of Korea. I'm not sure if the date's actually correct, it probably is, but it's just an example we typed up. So this might be complete nonsense. Anyway, we have the parameters, which is an object, and the properties are a list of happenings, which is of type array. The description of this array is an array containing arrays with dates in index 0 and happenings in index 1. Then inside this list of happenings, we have the items that go inside. They're also of type array because we have an array of arrays, arrayception. The description is an array containing a date. Oh, I actually made a typo here, a date and a happening. The date always comes first, the happening second. So the items inside this array again, notice the nesting, is we first have a date, which is of type string. Description is the date for the happening. Then we have the happening, which is of type string, and the description is a single sentence description for the happening. And again, we provide the same example of the Battle of Waterloo. And then finally, we have required list of happenings because we need this array, of course. If it calls the function without the array, then it would be completely pointless. So that's the function description, and we're just trying to get ChatGPT to call this function and give us an array of data, which is our only goal. So go ahead and close this file. And now let's get some text to use. Now, I'll be using wikipedia.org/wiki/history of Korea as my example text. You can also use a different text, but if you want to use the same text that I used, I just selected this from here all the way up to the prehistory heading. This is the text that I'll be using. I'm just going to copy it, and then I'm going to make a new file in my base directory named ex text data.txt, and I'm just going to paste this in here, and this is going to be my text for this exercise. Note that if you use a very large piece of text and run the code we're about to make many times in a row, you'll use about $10 worth of GPT credits over all the runs combined. If you run it many times, it's going to be 1/10 of $1. So still not a big deal, but the large parts of text we send to ChatGPT do add up slightly quicker than normal calls. So just something to be aware of. I ran the code quite a lot of times for testing purposes with this reasonably long text, and it still only came to 1/10 of $1, and I ran it many more times than you will probably for testing this and that. So no worries. And we can make sure you save this from now. And actually, let's extract some data. So create a new file. I'm going to call it EA non-existent functions.py to get it to slot in here nicely. And let's start with our imports. Up top, we import JSON, then our color printer, or read text file utility, or GPT turbo call, or data extraction setup, and our function description. And again, we'll be using the JSON import to load the arguments. Okay, so we start our function, which takes text data as an argument. We have the messages, of course, our setup in the first one, the text data in the second one. We define our functions and make the first call. We make sure to force the function call of our non-existent function. We get the current response, the current message, and we append this to the messages. Now, if the current message has a function call, which of course it will because we forced it, we extract the function arguments as structured data, which is a dictionary. And then we get the list of happenings, which is a list which is located in the structured data list of happenings key, because this is what we requested specifically in our function description. It was supposed to be a list of happenings as the property. So that's where our list of happenings will be located. Then we use our color printer to print out the messages, and for each list item in the list of happenings, we're just going to print out the list item for now, just to see that we actually got our structured data as we're trying to get. So now let's continue below and outside our function. We define text data, which is our read text file utility we made, and we give it the text data we saved in this file before. Then we run extract structured data, passing in our text data. So let's run this and see what we get. And let's just give it a moment to run, because we're passing quite a large query, which is all of this text, of course, for ChatGPT to process. So it will take a couple of seconds. And there we go. So we have our system setup message. Then we have the user query, which is all of this text, so it's really long. Then we have the assistant calling make list of dates, which gives us this object exactly in the structure we requested. Now that's pretty damn cool, isn't it? We have an object with a list of happenings exactly as we requested, and this is a list of lists with something representing a date and a description of what happened in the first index or the second slot. So we don't have to parse this. This is an object. Well, we do have to parse the JSON, but it's not a text response. It is an actual object response, and we can just work with this and loop over this and just have an object right away. So while this is not perfect, this is still pretty damn cool. It does have some limitations though. For example, you cannot ask ChatGPT to order these dates for you. ChatGPT does not do iterative loops over data. It's kind of like a river that flows down wherever the flow takes it, and it has no idea of where it's going. It has no memory of where it came from. It only knows where it is currently flowing. It's still pretty cool though, as we no longer have to parse this data ourselves. It's already present in Python list or dictionary format or whatever you want it to be. And I'm sure this will get even more robust in the future. So let's move on to the next part, where we'll be looking at some of the pitfalls and how to handle the slightly less predictable nature of AI. Our usual and totally deterministic manner of programming is reasonably predictable. We run the same code, we get the same response. We generally know what will happen when we run our code. But AI is a little bit more unpredictable, and we'll look at some ways to handle this. First, let's take a quick look at a library called Tenacity. Run the following command in your terminal window to install Tenacity. Now, I already have it installed, so it's just going to say it's already requirement already satisfied or whatever. And this library is a retrying library. It allows us to retry a function call if it fails. Now, ChatGPT won't normally fail to return a response. It will just tell you that it doesn't know. Although there are actual errors like server overload that occur occasionally. But when we start calling functions, we have the potential for our functions to crash and burn if ChatGPT fails to provide the correct arguments. Though this doesn't happen often in my experimenting, even with GPT 3.5 as opposed to 4, we should still take some measures. So let's explore how Tenacity works. Create a new file in your base directory called, it's getting longer, so I'll just expand this slightly, ev handling failures with tenacity.py. And let's add our imports first. We import some stuff from Tenacity, and we'll explain this in a moment, and our own simplified GPT Turbo 3.50613 function. Now, let's create a GPT call that will artificially fail a couple of times before it succeeds. So let's go below here. And we first define a simple variable fail counter and set it to 0. Above our function, we use the add retry decorator from the Tenacity library. We set it to stop after 3 attempts. This means that if the function defined below crashes out, it will try a total of 3 times before giving up. We then define our function askGPT, which takes a query as argument. We then simulate a failure by incrementing. We first reference our global fail counter, so we can use it in here. Then we increment it by 1 every time it runs. And if the fail counter is less than 2, we raise a value error, GPT failed. So this is going to fail once, twice, and then the third time it will just run as normal and run the query and return the response. And we just have messages here with the content, what is the capital of France. So this is what we're going to ask 3 times. Then we actually run our function call below here. So this will crash and burn twice and then succeed the third time. And let's run this. And you'll see we never got any sort of error message because it just ignored the errors and it tried 3 times, and the third time it worked. Now, if you don't believe me, go ahead and comment out the retry decorator, which means we'll only try to run the function once, and you'll instantly get a value error, GPT failed. So this is actually retrying, and that's why it's not failing. So if there is an error, it will try again before giving up instantly. And we can also use the Tenacity library to try and give up after a set amount of time has passed. So in this case, we have a retry decorator. We stop after a delay of 3 seconds. So it's going to try for 3 seconds. We define a silly function. This is called try something stupid. And we print trying to do something stupid and dangerous, but it's going to fail every time because we raise an exception within this function. Something stupid and dangerous happened. So it's going to try calling this function for 3 seconds and then it's going to give up. Let's call this function, and for 3 seconds we'll get lots of spam and then it actually fails. So we'll retry for 3 seconds before giving up. And you can also combine trying for a certain period of time or a certain number of attempts. So I'll show you another example below here. stop after 10 attempts, or stop after a delay of 5 seconds. And we define eat watermelon in 1 bite, trying to eat a watermelon in 1 bite, which raises an exception because you cannot eat a watermelon in 1 bite. And we're going to run this. And of course, running it 10 times is much faster than, what did I say, 5 seconds. So it just runs 10 times and then it fails. So we can also put in waiting times between retries, implement exponential backoff, have different timings and whatever. Check out the Tenacity docs if you want to learn more about these details. But you should always think about adding a retry somewhere, especially when incorporating a non-deterministic type intelligence into your code and having it call functions with AI-generated arguments. The point is, if the arguments don't make any sense, your function is going to crash out, and you may want to just retry once or twice before giving up and giving the end user an error, because ChatGPT may actually come up with a pretty good answer if you just run it once more. The same goes for our database example from part 4, where you should have a failsafe of catching an error that might occur on an incorrectly generated SQL query. The easiest way to add a failsafe is to add the retry decorator to our ask company database function and have it just make the call once or twice more if it fails. Alternatively, we can also send the error code back to ChatGPT. So we append a message that the function call failed, and we ask ChatGPT to call the function again, but this time with a correct SQL query. And then we have to convert this to the while loop structure that we had in our multi-calls here. So we have to make sure that it's while is calling function, so we give it the opportunity to call multiple functions in a row. And then we can just send the error back to ChatGPT, ask it to try again, this time with a correct query. And then we just try to run the query again and see if that one errors. So that's also a very good way for these SQL queries in particular, to just send it back to ChatGPT. The SQL query generated was not valid. Please try calling the function again, passing in only a valid and fully formed SQL query, or something like this. Yet another option is to wrap the database SQL call in a try except block, and if it fails, you append not the function call response to the message history, but a message with the role of user and the content of your SQL query was erroneous. Please try calling the same function again with the corrected SQL query. That's basically the same as sending it as a failed function response, but ChatGPT will tend to listen very well to what it thinks is the end user's instructions, so this might be particularly effective as well. So you can just send errors back to ChatGPT and just have it call functions again, as long as you use this structure where you give it the opportunity to make multiple function calls in a row. To ChatGPT's complement, I've not actually had much trouble with erroneous SQL queries or erroneous function arguments so far, even with GPT 3.5. So I've not had to use this a lot. But for a production environment where high reliability is a top priority, one of these extra failsafe methods is definitely worth considering, which is why I feel it had to be mentioned. Now that we've had a lot of fun with function calls, it's time to have our minds blown again in the next part, where we'll take a look at an equally amazing feature called embeddings. I'll see you there.